In this video of the Mind Simulator TMS, we're going to discuss data distributions and how they are applied and specified in the input spreadsheet for TMS. To define data distributions in the Mind Simulator TMS, you first go to the main menu, click on the General tabs and then the Distribution tabs. Here you'll see a list of current distributions that are in MindOpSim that have been used for different projects over the years and haven't been removed. A data distribution is just a way of specifying a range of data or a distribution of data, and what the simulation does, it hits that data distribution with a random number to extract a value from that distribution which it then uses. For example, you can see here at some stage we did a payload variation. It's just a uniform distribution. That means it's from one point to another, and all values between those numbers have an equal probability of occurring. So it ranges from -3 to 3%. So the payload variation will range from -3 to 3%. So the simulation hits this. So it'll hit it once and say, well, the payload variation on this truck is 1%. Then it hit it again and say the payload variation is 2.2%. Then hit it again for the next truck and say the payload variation is -1.8 or whatever it is. So this is how you define the payload distribution. So there's a whole pile of them in here already, but you just add them in when you have new distributions to add. So when Arena offers a utility that you can take a list of data and it will do a best fit distribution to that particular set of data. I'll actually go through that on a separate video, and from that it will actually generate these parameters that go into here. So for a log normal distribution, it's a mean and a standard deviation, a log standard deviation. In TMS you can also use these factors to factor the distribution up and down. So this particular distribution here is for loading a specific type of ship, a post-Panamax ship. It's the gross load rate, and it averages about 6,000 tonnes per hour, but it's got an average of 6,000 plus a standard deviation of 167. So we can use that distribution, and then if we want to run a simulation and say, well, if we want to increase the load rate of loading post-Panamax ships by 10%, we can change this. We can just, instead of doing distribution, we can just change this factor to 1.1. So then it'll still, the simulation will hit this distribution, come up with a value, and then factor it up by 10%. So that's an easy way of doing what-if analysis in the simulation and just factoring up the distributions. You also put a min and maximum value in here. It's very important, especially when you're using log normal, which may have a really long tail or what have you. You want to put a maximum value in there as such. So the simulation will accept, we can put in many different types of distributions. Weebles are often used for breakdowns and information like that. So we can specify these sorts of distributions. So in the simulation, you can specify a distribution like this is for gross load rates for ships. And then in the other parts of the spreadsheet, like here, you're talking about the ship loader. So these are two ship loaders in this particular simulation. And in here, you can specify that for ships that are less than 82,000 tonnes, we're going to supply this sort of gross load rate. So in the simulation here, you could put in a gross load rate of 5,000 tonnes per hour as a positive number, or you can put a negative value, and when it's a negative, it's pointing to a distribution. So here, for these ships less than 82,000 tonnes, we're using a distribution of -55. So if then we go back to our distributions and look at number 55, so here it is here. So this is the distribution for these ships under 75. So it applies that in the simulation. So throughout the simulation, different parameters, if you want, you can specify as constants, or you can attach a distribution from this particular list of distributions. So that's about it on defining distributions in TMS. Thank you.